Hello and welcome to this video about pandas for data handling. We're excited to have you here, and in this video we are going to talk about pandas operations and techniques. In this video we will talk about merging pandas data frames. Pandas data frame merge method is one way to add two data frames together horizontally into one data frame. The merge method is both useful and powerful for situations when a data frame's column or index column need to be aligned with another data frame's columns or index column. This is very useful when data frames or data are structured in a similar fashion as standard query language database tables. For example, if standard query language database tables have been retrieved to data frames, and there is a data storage model with all aspects of a standard query language database available. And the merge method provides us with some new tricks. The merge method extends the join method to columns versus column joins. The merge method provides us with inner joins as default, left joins, right joins, outer joins, and cross joins. And the reason that the inner join is default is because the merge method is very powerful and can create time and resource consuming work if improperly handled or used without prior exploration of the merged data frames. And the merge method treats duplicates with Cartesian products. And this means that duplicates may create very large data frames when used with the merge method. And the merge method is quite advanced and has a more complex argument syntax than the pandas data frame join method. And the merge method is near equivalent to the join method if you only are using the index for joins as in a proper join. And the merge method will ignore the indexes when joining on a column-to-column basis. And we can say that the merge cross-join is similar to a join cross-join and don't allow the use of columns for cross-joins. So currently, the cross-join for a merge method is similar to a cross-join for a join method. And one particular issue with the merge method is that it treats null values as proper keys, which can cause unexpected results such as large Cartesian products. And a consequence is that the merge method should not be used on uninspected or unknown data in automatic processes. So don't use the merge method blindly. Inspect the data first and don't let data be unknown. For example, if you have a large number of null values or missing values, they can be treated as merge items. And this means that if you have, for example, a database with 1 million rows and you have missing values in, let's say, between 5 to 25% of these rows, the Cartesian product may grow to literally the sky is the limit. So this is something to think about with the merge method. So all right, to sum it up, we can say that the merge method extends the join method, that the merge method is slightly different, and that the join types are similar, but when talking about the extension, the merge method can be used on suitable types of features in the data frame such as columns. The merge method may be used on different types of columns in the data frame rather than indexes. So for example, on the second joining data frame, you can join the first data frame with column in the second or other data frame. So all right, now we'll type some code to start up your code editors. All right, having started our Jupyter Labs notebooks, we will now type some pandas data frame merge code. And as you can see, we already have some code typed in our notebook. And this code you can download from the course lecture as a resource if you don't want to type all of this code. So you can simply cut and paste it from the PI file attached to the video lecture. And this code is our basic car sales data frame, which we have extended with 2 more sales places. And we have the additional special feature for this video lecture that we have transformed the index column to a feature column. And this is necessary for many merge column joins, as the index is not used for the merge, and the features of the merge makes the index redundant as a list of unique labels. And therefore the index is most often dropped when you are executing column merge. And therefore we have transformed our index to a feature column. So first we have the basic car sales data frame. We concatenate it with the extended data frame. We make sure to have an index with the name sales place. We rename the index name. And we use the reset index instruction in place to create a feature column from the index column. And the second data frame we will use includes some invented car inventory data. So we have unique column names for sales place name, which are all included in the car sales data frame. And we have made sure that there are fewer labels than in the car sales data frame, and this is solely done for pedagogic purposes. So we have sales place names, and we have car inventories. This imaginatory fictitious data is about having 132 cars in the Europe 1 sales place. And the third data frame is of the same type. But here we have non-unique column values for sales place name, and some of these are included in the car sales data frame, and we have more labels than in the car sales data frame. So we will use these 2 extra data frames to show the effect of the merge operation on these data frames. All right, the first thing we will do is that we will import the Pandas library. So we type import pandas as pd. And we run this code to check that everything has been created properly. And here we can see that we have our standard car sales data frame extended with 2 extra sales places. And we have transformed the index column to a feature column. So here we have a sales place column with the index labels as string data. And this makes it possible for us to track the rows of the data frame during the merge operations. And here we have the second data frame with fictitious car sales data frames. And here we can see that every sales place name is unique, and that there are fewer labels than in our car sales data frame. And we have also made sure that all these labels are represented in the car sales data frame. And in the third data frame, we have more labels than in the car sales data frame, and we have labels which are not represented in our car sales data frame. All right, let's begin with the standard inner join merge on two columns. We type print car sales merge inventory data how equals inner. We will be very clear here, so we type on none to make sure that we have on none. This is actually the default instruction, but to make this clear, we type on none. And left on, we choose the sales place name column. And right on, we use the sales place name column. And we close the print instruction. And this instruction will execute a merge using a inner join on our car sales and inventory data. And in this merge, we will use the sales place name columns in both data frames. So we will use this column on the car sales data frame, and we will use this column on the inventory data frame. So let's run this code. And here we can see that the order of the indexes are from the first data frame. And here we can make the observation that our sales places is still unique identifiers of the rows, and we can see that the data frame has been sorted behind the scenes, and that the car inventory column contains correct data, but that the data is considered to be implicit duplicates, as there are two excessive sales place name duplicates. And this is very interesting, because when you will use these instructions and commands, you can never really be sure about the contents of the data. So you need to know, and you need to inspect, and you need to understand the data. So here, for example, we have several objects within a object, and these objects has their unique summations. So this is important to keep track of, because if they ask you for the total car inventory, for example, and you make a sum out of this, you get a vastly larger figure than you should have, or which is correct, which also is an interesting question. So now we'll use the car sales 2 data frame with the same instruction. We cut and paste this column, and we put a number 2. And we run this code. And here we make some observations. We have duplicates on the sales places. And this is plus 1 row. So here with our inventory data 2 data frame, which has 2 Europe 1 sales places, and presumably this is actually the same sales places, but someone has typed 2 estimates for the same continent. First it was 131, and then he entered 132, and 131 never left the database. And when we used the merge instruction on these 2 data frames, this extra data entry created a duplicate in our resulting data frame. So this is important information and important knowledge to know when you use the merge operation on data frame columns. You must inspect and know about the data, because these operations are data dependent. So let's use the standard left join merge on 2 columns. And we will reuse our code, and we will change the inner join to a left join. So let's run this code. And here we will make observations. And we can see that the left join preserves the order of the rows in the car sales data frame. The implicit duplicates in the car inventory column remains. And normally, when we use these instructions on this type of data frame, the inner join and the left join would be considered the correct join methods for these data frames. And we can try the other data frame. So we reuse the code, change the data frame, and we change the join type to left, and we run this code. And here we can make the observation. We have duplicates on the sales place row +1. And this row has been created for the same reasons as in the first time that it appeared. We simply have one data entry too much in the data inventory 2 data frame. And this is the practical explanation for this particular case. And in other cases, there might be other explanations. And how to handle this is a matter for the subject matter expertise in each and every case. All right, now we will use the standard right join, merge onto columns. And we will reuse our code and we'll change the join type to right. So let's run this code. And here we make the observations. That the merged data frames are sorted on the inventory data frame. This is important. We have 1, 2, 3, 4, 5, 6, 7, and 8. And this is sorted on this data frame. So here we see Europe, Australia, United States, Asia, and so on. And here we see Europe, Australia, United States of America, Asia, and so on. And we will try right join merge on the other data frame. We change to the other data frame and we change the join method to right. So let's run this code. And here we make the observations. That we have duplicate on the sales places. And we have +3 rows. And 2 rows mainly consists of missing values. So here we have Canada 1, and we have South America 2, and they have no representation in the car sales extended data frame. And therefore, there is no data for them, and they create missing values. So here we obtain 2 rows, which mainly consists of missing values. And we obtain 1 duplicate row for reasons which we already have discussed. And if you remember the introduction theory part of this video course, these not a numbers are currently considered labels by the merge column method. So if you have, for example, a data frame with many missing values or null values, these values, when you merge, will be considered to be labels and label duplicates. And the merge method treats these by creating Cartesian products of them. So if you have many of these null or missing values, they create huge data frames, which has the capacity to grow to the sky, meaning that there is a roof for the sky, but you don't really know where it is unless you have investigated and calculated on it beforehand. So this is something which is important to understand. And we will try to use the standard outer join merge on two columns. We reuse our code and we change the join type to outer. So let's run this code. And here we can type that we make the observation that in this case, the outer join is nearly equal to the inner join, because of the data in the joining data frames. So what we see here is a data-dependent result, which is quite unusual, except in the most tidy of all data environments. And these type of data sources mainly exists in the most professional data science environments. So let's try the outer join on our other data frame. We reuse our code and we change the data frame and we change the joining method to outer. So let's run this code. So here we make the observations. We can see duplicates on the sales places plus 3 rows and 2 rows largely consist of missing values. So we can conclude that given the properties of these data frames, we can see that the outer join in this case is resulting in the same result as a right join. And this is quite interesting, but we must also know that if we change the properties of the data frames, we can achieve other results. And this is a very good exercise to work on, to change the properties of these data frames and watch how the result of this very powerful method changes when the properties of the data frames columns change. And this is important to know because this method is extremely powerful and you can do a lot with it. But just as with powerful or complex or complicated other things, you must also know how to handle them. And it is very important to know all these things. So, all right, in this video, you have learned a lot about the fundamentally useful Pandas data frame merge method. And we look forward to see you in the next video.